What if an AI couldn't just solve a math problem, but could do it in a way that shows us a totally new way of thinking? Well, that's exactly what we're digging into today. A landmark moment where artificial intelligence didn't just compete with human mathematicians. It actually showed us a different path to the same truth.
12 out of 12. That's a perfect score. And get this, it wasn't a human who got it. It was a new AI system at the 2025 Putnam mathematical competition. Now, if you're not familiar, this is a legendary exam so tough that more than half of the brilliant students who take it, they score a 0.
Yeah, the Putnam is notorious. It's not about just crunching numbers. It's a test of pure creativity and deep, deep insight. I'm talking about a challenge that stumps even professional mathematicians on a regular basis.
Okay, so a perfect score is shocking, for sure. But the way this AI did it, that's the real story here. It tells us something really profound about two very different kinds of intelligence, ours and the machine's. All right, so let's meet the system that pulled this incredible thing off, Axiom Prover.
This isn't just any old AI. Axiom Prover is an autonomous system, and what it produces are these fully formal machine-verified proofs. So unlike AIs that might, spit out text or ideas that could have flaws, Axiom Prover's output is pure, unadulterated logic. It's basically code that is mathematically guaranteed to be correct. No ifs, ands, or buts.
And this right here, this brings us to the huge gap between these two ways of thinking. A human mathematician, they kind of see why something is true. They rely on intuition, on mental pictures. Axiom Prover, on the other hand, it doesn't see anything. It checks every single logical step to confirm something is true. It's all about pure end-to-end logic. So what happens when you pit these two very different approaches against the same problems? Well, let's start with questions that are, obvious to us humans. But for the AI, they reveal this hidden, almost brutal level of complexity. Okay, let's take a couple of pretty standard calculus problems from the exam. For a person, you can often just see the answer with a quick sketch of a graph, right? You use words like clearly or obviously. But here's the thing. For Axiom Prover, there's no such thing as obviously. It has to build the entire logical case from the ground up, proving continuity, defining what a derivative even is, checking every single boundary case. It's exhaustive. And this just nails it. A little side proof, a lemma that feels completely trivial to a human, can take over 60 lines of formal code. It really shows you the difference between what feels simple to us and what is formally simple to a machine.
And this gap gets even wider when you look at combinatorics. The human idea for solving one of these problems, it was described as very natural, just a few paragraphs long. But to translate that natural idea into a formal proof that a machine can verify, whoa, the AI can't make any assumptions. Every index has to be tracked. Every single identity has to be spelled out from first principles.
So how many lines of code did that natural idea take? 2,054. Let that sink in. The Axiom team has a name for this. They call it the tax of absolute rigor. Okay, but here's where the story takes a really interesting turn. Let's look at the problems where Axiom Prover actually surprised everyone, especially in areas we thought were exclusively human territory. Think about it. For a really complex geometry problem, what's the first thing you or I would do? We'd grab a pencil and paper, right? We have to see it to understand it.
We humans, we crave diagrams. We think spatially. But Axiom Prover? It solved a seriously tough geometry problem with a purely symbolic argument. It reasoned algebraically, just tracking vectors and distances, without ever needing to see a picture. It got to the same truth, but through a completely alien cognitive process. It's wild. And then there was problem A6. This one was rooted in a super complex field called p-adic arithmetic. It's this strange world where our normal intuitions about numbers just totally break down. And on this one, the entire human team, they got stuck, hit a complete wall. So how did Axiom Prover solve it? Well, its approach wasn't elegant or beautiful. It was a brute force symbolic grind that took hours and hours. But it worked. This wasn't a flash of genius. This was relentless, mechanical correctness, just powering through where human intuition had failed. This brings us to maybe the most fascinating part of all this, the problems where both humans and the AI found the answer, but they took completely different roads to get there.
So on this one difficult matrix problem, the human team's instinct was to go for algebra, but Axiom Prover, it chose a completely different path, a geometric one. It reframed the whole problem in terms of vectors on a circle. And with that new perspective, the problem just collapsed. The AI didn't just solve it, it actually found a better, more elegant way to see it.
So, what does all of this mean? Where are we headed? Well, the results seem pretty clear that the future isn't about AI replacing us. It's about a powerful new kind of partnership.
You can start to see this amazing new workflow emerging. We humans, we're great at generating the big ideas, the concepts, deciding what matters. And the machine? It's unbeatable at checking every single detail, exploring these vast logical spaces, and catching all those subtle errors that we'd miss. The Axiom team has this perfect metaphor for it. The machine grinds the beans, the human tastes the coffee. The machine's formal, rigorous checking grounds our intuition, and our intuition, in turn, inspires the machine's exploration. They feed each other.
And that's really the big takeaway here. This amazing achievement isn't just about an AI winning a math competition. It's a real glimpse into a future where human creativity and machine rigor can actually combine. We're moving beyond just checking everything and into a new era where we can truly start thinking together. And the only question left is, what are we going to discover first?